Okay, so a traditional and widely accepted flexible pavement design procedure is presented in the AASHTO Guide for Design of Pavement Structures, which is published by the American Association of State Highway and Transportation Officials. So, a pavement can be subjected to a number of detrimental effects, so that includes fatigue failures or cracking, which is a result of repeated loading caused by traffic passing over the pavement. The pavement is also placed in an uncontrolled environment, so that produces temperature extremes and moisture variations. The AASHTO pavement design procedure meets most of those demands placed on flexible pavement design procedure. So for the serviceability concept, the pavement serviceability performance concept was developed by Curry and Eric in 1962 to handle the question of pavement failure. Curry and Eric considered pavement performance histories and noted that pavement usually begin their service life in excellent condition. So, once na makonstruct siya, the service life begins in an excellent condition and deteriorate as traffic loading is applied in conjunction with the prevailing environmental conditions. Rigid pavement distribute wheel loads by the beam action of the Portland Cement Concrete or PCC, which is made of a material that has a high modulus of elasticity on the order of 4 to 5 psi or pound per square inch. This beam action illustrated in the figure distributes the wheel loads over the large area of the pavement, thus reducing the high stresses experienced at the surface of the pavement to a level that is acceptable to the subgrade soil. So, ganun pa din yung sinasabi dito. Yung purpose ng pavement is para matransmit yung load sa ating subgrade or sa soil at a larger area para mas maliit yung stress. The AASHTO design procedure is applicable to the following. So we have the jointed plain concrete pavements, then the jointed reinforced concrete pavement, continuously reinforced concrete pavement. So yung joint plain concrete pavement, yun yung na-discuss natin kanina na rigid pavements. Plain siya, pero meron siyang joint. Meron siyang joint, wala siyang reinforcement. Ito namang jointed reinforced concrete pavement, meron siyang reinforcement, meron din siyang joint. And then the last one is the continuously reinforced concrete pavement. Meron siyang continuous reinforcement pero wala naman siyang joints. Yun yung isa sa mga other types ng pavement na na-discuss natin earlier. So, in the measurement of pavement quality and performance, the design procedure for pavements originally focused on the Pavement Serviceability Index or PSI. So, yun yung ginagamit na measurement ng road quality. However, the Pavement Serviceability Index is based on the opinions of a panel of experts which can introduce some variability into their determination. Since different experts has different opinion, so magkakameron ng variations. As a result, efforts have been undertaken to develop quantitative measures para magkameron tayo ng quantitative basis of pavement condition that provide additional insight into pavement quality and performance and that correlate with the traditional pavement serviceability index. So, yung factors na regularly minimeasure by highway pavement agencies now include the International Roughness Index, friction measurements, and rat depth. So, ito yung mga naging product ng efforts na ginawa para mag-develop ng quantitative measure of pavement condition. So, the first one is the International Roughness Index. So, paano ba siya nadidetermine? So, gumagamit tayo ng standardized vehicle suspension. So, minimeasure natin yung vertical movement of that suspension per unit length of roadway. So, the units of IRI are reported in inches per mile. And the higher the value of the IRI, the rougher the road is. Since kapag rough yung road, mas malaki yung vertical movements na mabubuo doon sa suspension. So, pagtaas ng IRI, paggaspang ng ating road. We also measure the friction. So, paano ba siya ginagawa? To estimate friction, a standardized test is conducted under wet conditions using either a threaded or smooth tire. So, maalin sa dalawa. Usually, ang ginagamit na test speed is 40 miles per hour, but it may vary. Gumagamit tayo ng friction testing trailer. Ang ginagawa is inilalak yung wheel doon sa wetted road surface. Then yung makikreate na torque doon sa wheel, yun yung gagamitin para ma-measure yung friction number. So there are some factors influencing the friction number. First one is the changes in traffic volume or traffic composition. Next, surface age. So friction has been found to increase quickly after construction, then as time passes to level off and eventually decline. Then we also consider seasonal changes. So in northern states, the friction number tends to be highest in the spring and lowest in the fall. And the last one is the speed. So the measured value tends to decrease as the test speed increases. Since yung ginagawa naman nating test sa friction measurement ay naka-standardize sa 40 miles per hour. So it may vary depending upon on the speed used.